Alright, let's do a quick one. Let's do a random design. Happy Veterans Day too for everyone out there. So range sum query 2D immutable. Given a 2D matrix, handle multiple queries of the following type. Calculate sum of the elements of the matrix inside the rectangle defined by its upper left corner and lower right corner. Okay. Inside the rectangle defined by its upper left corner and lower right corner. Okay, so all the way there, all the way here. Okay. And constant time complexity? Whoa. That's actually kind of crazy. How would that even work? So like we just a num matrix. So 2 1 0 1 2, and then the first row or first column, then 4 3, which is 0 1 2 3 4 0 1 2 3. So everything inside the square. So my initial thought is all the rows I feel like if you what happens if I flatten it? Would that make a difference? I have an idea. I feel like if you flatten the array, right? So let me just try that, right? I flatten the array. Let's just ignore the brackets. Somehow, would I be able to calculate this? Because I don't know. Let's see. So we have here 0 1 2 3 4. We know this. So 2 1. That's 0 1 2, and this, and then we have 4 3. So let's just start this, and then 4 3. So 0 1 2 3 4. 4 3. That should be 0 1 2 3. So yeah. Is there a pattern? It actually kind of looks pretty. No, I can't. See, that's the problem. I don't want to. So, like, I would add all of these, but I would not add this. Right? But I would add this row below me, and I will add the row below me again. Well, okay, my intuition is just like, I don't see, okay, would flattening help? Doesn't seem like it. But having the shape of it seems to be fine, right? Let me, is there any other thing here? Prefix sum. True, I could calculate something else. Let's just try the brute force. I think it's fun. Self-dot matrix equals matrix. And then we'll just like do something like that. So we'll just do the brute force. Because I think the prefix one is a bit too mathy. So, alright, so I think basically I start at 4r in range of, so basically I want to start here and add like this, or like maybe go like this too. Well, okay, I prefer the, let's do RC or row 1, call 1, or we can just take those values. So while row 1, or that's like the bounds. So I actually want to, okay, so start is, yeah, I want to start here, and these will be our bounds, like of how far I can move these, right? So that's why I'll make a copy. So RC will start from row 1 to row 2. So for every R, so while we don't want to go farther than past this row. So while R1 is less than row 2, and C is less than row 2. Yeah, that makes sense. I don't want to go like past where this is. Like, this is just the starting point. Now how far I go down, yeah, that makes sense. We can R decrement, yeah, it's always pointing down, you know? Yeah, so I can always go down, and C will go to the right. Well, first I need to collect all the, okay, I see why I have to do a double for loop. Let's do a for loop. So 4 are in range starting from row 1 to this row. So that's row 2 plus 1 maybe. So like I include this one, like 0, 1, 2, 3, 4, 5. It'll point at 5, but I'm not gonna be actually on 5. Actually, I want to include that. So yeah, start from here to there, and for every column, for every call in range of call 1 to call 2 plus 1, like I want to, so from this row I want to go Yeah. Yeah. And then res plus self dot matrix of R C. Does that make sense? Okay. Kind of slow though. I think it might actually TLE, to be honest, because it is brute force. Yeah. That sucks. Okay. What's the optimal? Let's see. Caching. Okay. Okay, I'm not reading this. Let's go to a solution. Yeah. That looks pretty ace. DP? This is a DP? Wow. My goodness. So they have they build out some matrix that computes the sum. Let's see. So for this, we need to calculate the prefix sum array for the matrix. So prefix sum a matrix with each cell 1. Let's say we want to find the sum of the following region, 9, 12. We first need the sum from each of the following regions, everything. Region here, and then region here, and region there. Then we can calculate region A minus B, that gets rid of this, so we're only left with that. Then we get rid of this, plus D, which remains with this. Okay, that's so complicated. This one looks a bit more readable. So bottom right, above left, that. All right, let's try it. M and N. Matrix. Self.acu sum. I guess we could say prefix. It's n plus 1, 2, 4 underscore in range of plus 1. So we take every single value, take the prefix. So prefix plus above is the row plus 1 and the C plus 1. I see. For M and N. This part is kind of confusing though. The sum region is just row plus 1, col plus 1, row plus 2. The bottom right, okay. This, this, this. I see. Okay. A prefix sum of the matrix. Ah, this is so tricky. It's a bad problem. Left up diagonal. Left up diagonal. Similar, but I saw an explanation for the recurrence. I used 1 unit difference. These were the separated reason to variables. Yeah, makes sense. Alright, I'll revisit this next time. That's gonna for today. See you guys tomorrow.